Okay, Unit 4, quadratics. We're going to start off by solving quadratic equations by the method of factoring. So before we do that, I wanted to review all the different types of factoring methods. So here is classic GCF extraction. Here is trinomial trinomial factoring, where A is equal to 1. When I mean A equals 1, I mean the coefficient of the squared term, or the leading coefficient, is equal to 1. Here we have a classic difference of perfect squares. And here we have trinomial factoring, where A is greater than 1, and we can't really factor out a greatest common factor to make this easier, so we must split the middle term and then factor by grouping. 3 times 24 is 72. We'll look for two numbers that multiply to give me 72. And we're going to go with 8 times 9 is 72, because 8 minus 9 is negative 1. So we're going to split the middle term. 8n minus 9n, we factored by grouping now. So I group them together like this. Extract the n, extract the negative 3, and we have, this is our factored form of this trinomial. Last one is just standard grouping. X squared minus 1, 6x plus 1. We're not done yet because x squared minus 1 is a difference of perfect squares, which we can further expand out to x plus 1, x minus 1. So now that we have reviewed all the different methods of factoring, we're going to basically add an equal sign and a 0 to the right of each expression, like this, so that we're going to actually solve the equation and solve for the variable that satisfies this equation. So here's our equals 0, equals 0, equals 0, equals 0, and equals 0 over here. Okay, and let's go back over to here, because this is the method we're going to use to solve the quadratics is factoring. Now remember, there is something from Algebra 1 that you learned called the zero product property. If the product of two expressions is 0, then one or both of the expression equals 0. Algebraically, you could explain this by saying, if A times B equals 0, then one of these has to equal 0, or both could be equal to 0. And finally, here's an example. If x plus 5 times x plus 2 equals 0, then we set each of these factors equal to 0, and we get x equals negative 5 and x equals negative 2. Now, sometimes your quadratic equation is not going to be completely solved with 0 on one side. So you have to combine like terms, subtract, or add terms to get that 0 on one side of the equation. So now that we have p squared times p plus 6 equals 0, we know that this is one term. This is another term that multiplied each other to get 0. So that means p squared equals 0, or p plus 6 equals 0. And I draw this vertical line here to basically split it up into two separate equations. And we know that to solve this, the square root here and square root here. So p equals 0, subtract 6, and p equals negative 6. So our solution set for number 1 is negative 6 and 0. Number 2, we have a minus 7 equals 0, or a minus 8 equals 0. Add 7, our solution set is 8, 7. Number 3, classic difference of perfect squares. We set each of these factors equal to 0. We subtract 2, add 2, divide by 5, and our solution set is negative 2/5, positive 2/5. Number 4, this was our factoring by grouping and splitting the middle term. So we have 3n plus 8 equals 0, and n minus 3 equals 0. Subtract 8, divide by 3, n equals -8/3. Add 3 on this side, n equals 3, and our solution set is -8/3, 3. Last one, number 5. We're going to go ahead and, since we have 3 factors, we're going to have 3 equations. X plus 1 equals 0, or x minus 1 equals 0, or 6x plus 1 equals 0. Subtract 1, add 1, subtract 1 over here. These two are done, but this one we need to divide by 6. So our final solution set is -1, -1/6, and 1. Let's take a look at a couple other examples. Here we need to add or subtract the terms to get 0 on one side of the equation. So I'm going to add 7n and subtract 15 to keep that 2n squared positive, keep that 2 positive, because I prefer to keep the leading coefficient positive. And that leaves this right here. I'm going to split the middle term. 2 times 15 is 30. I'm going to use 3 and 10 because 10 minus 3 is 7. So we have split the middle term, and let's factor by grouping. n plus 5 times 2n minus 3. Set each one equal to 0, and our final solution set is -5 3/2. This one's pretty simple. Subtract 3a on both sides. We end up with a squared minus 3a equals 0. Factor out the a. We have a times a minus 3 equals 0. This is going to be easy because we draw a line down the middle. A equals 0, which is actually done. And a minus 3 equals 0. We have to add 3 to both sides, and a equals 3. And last example we'll check out for the day. Here's r squared equals 25. We subtract 25 from both sides, giving us 0 on one side. And this is classic difference of perfect squares. So we have r plus 5, r minus 5. -5, 5 is our solution set. There's an alternate method, and that is we could have just taken the square root of both sides of this equation because they are both perfect squares. This would result in r equals +5 and r equals -5, because we know that -5 times -5 is also equal to +25. And this plus stacked on top of a minus is basically the lazy mathematician's way of writing two numbers, a +5 and a -5. Same solution set. There's your lesson. Best of luck to you.